So here we are talking about exponential growth and then also decay. So exponential growth is a quantity that increases by the same percent in each unit of time. So the big thing here is, in a little bit we'll see decay. That's something decreasing. But when we're increasing by the same rate for each unit of time, we'll see increasing, and we'll see a plus sign here. Guess what we'll see for decreasing? We'll see a minus sign. That's right. Here's our formula for exponential growth. So our answer, our amount, the total, will be equal to whatever our initial amount is, either our investment or the starting amount of a house or something like that. We're going to multiply that by 1 plus whatever the rate is. Now the rate must be written as a decimal. So if the increase rate was 5%, we'd have to change that to 0.05. Then it gets that's in parentheses, that gets raised to however amount of time, or the number of times that increase happens. What we're going to look at is typically going to be that things increase by a certain percentage every year, so that would be the number of years up here, but that can be different depending on the situation. So that's our formula that we'll be using, I think, here, because I think we'll see a lot of exponential growth. So here we go. You invest $1,000 in an account that pays 16% annual interest. Whoa, bad line. Annual interest. So we let it sit there for 10 years. What is that account balance going to be after 10 years? So things are growing 16% each year. So we will use this formula, A equals principal times 1 plus the rate as a decimal to the t. So our principal, our initial, there we go, investment is $1,000. The rate that it grows at is 16%, but we're going to write that as a decimal, so 0.16. Remember, divide percentages by 100, and you get the decimal equivalent. How long is this invested for? 10 years. 10 times will it compound or earn that 16% interest. So we get our answer, our amount after 10 years is going to equal 1,000 times 1 plus 0.16 to the power of 10. You can punch that all into your calculator all at one time. And then the survey says, or the solution is, $4,411.44. While that is a wordy question, right now we're not going to write a sentence to answer that. We could, maybe we should. We'll do that a different day. Man, that's honest to goodness truth, folks. If you invest $1,000 for 10 years, you let it sit there, you don't touch it, and 16%, that's a lot of interest. You have invested somewhere well, it's paying out well. That's what it would be worth. This is a cool one. So what if we have more time to invest? So your great aunt invested $40,000 in an account that pays 8% annually. Every year you get 8%. She did that in the year 1972. What is the value of the account now? So we're talking exponential growth. So we'll use this formula again. The amount invested was $40,000. The rate, last time we made 16%. This time we only made 8%. Now 8% as a decimal is 0.08. Take 8 divided by 100. That's what you get. How long is it invested for? If we don't make that much of a rate, that can't make a whole lot of money, can it? Oh, man. Well, so how much is it worth now? That's the question. What is the value of it now? Well, it's this year. As of right now, my watch says it's 2017. Pretty funny, huh? If it's next year, do 2018. 2017 minus 1972. That answers how many years this thing compounded, how long it was invested. That's 45 years. That's our T. So substitute everything in. We had $40,000 times 1 plus. Our rate was 0.08 to the 45. How much do you think that's going to be worth? $40,000, 8% interest, which is still pretty good. For 45 years, your great aunt is a millionaire. $1,276,817.98. Booyah. Last but not least, I thought it'd be good to just kind of get a visual on how this works, because you're probably a little bit shocked by that last answer. Well, homes can be a good investment as well. There's a lot of variables and scenarios that could make it grow in value or lose in value, and a lot of those things we actually don't have control over. But let's say in this case you purchase a house for $100,000. Let's say on average it appreciates or grows in value 5% every single year. What is the value of the home after every 5 years of ownership? So our principal, our investment is $100,000. Our rate is 5% or 0.05 as a decimal. And then our time is going to depend at where we are at in this home ownership. So to fill out this table here, our first answer, or our first amount, is going to be 100,000 times 1 plus 0.05. Our T, our independent variable, is 0 there. When you punch this into your calculator, I don't know if you're going to be surprised or not, but anything to the 0 power is 1. You're not surprised by that, are you? And so this all becomes 1. 1 times 100,000 is 100,000, which kind of makes sense. Like if you've owned this thing for 0 years, you just bought it, it's only going to be worth 100,000. So we can put that in right there. The only thing that's going to change here is, so it's still a $100,000 home when we initially bought it. That's our initial investment. But now we're investing that for 5 years. So 5 years later, how much is it worth? It'd be worth, are you getting $127,628 bucks? You know what? Let's just call it $128,000. Let me erase that. Oh, Bessie, I shouldn't have done that. Mr. P, naughty. Whoa. So we'll go 128,000. Let's just round to the nearest thousand. So after 5 years, by the way, I'm going to go up by every 2 lines I'll make worth $100,000. A K is usually 1,000, so $400,000. This is money. So after 5 years, this would be 150K. So we're just a little above the middle. Now you just keep on doing this, folks. In fact, you can, if you have a calculator that has a history with it, you can just recall that history and change the exponent to a 10. So you don't have to type all this stuff in. It's really slick. We'll actually do that a ton coming up this second half of the semester. So I'd encourage you to get used to doing that. It saves so much time. Here you should get about $163,000, $162,889. Let's just call it there. So at 10 years, we're sitting at 163, so above that mark. From here, I'm going to have to color code this because I'm writing kind of big. At 15 years, so you just change the exponent to a 15. Otherwise, everything's the same. Those aren't 11s. Those are quotation marks, meaning what's above it. At 15 years, you're at 207. At 20 years, you're at 265. Dang, so in that 5 years, that home appreciated about $60,000. 25 would be 338. And then at 30 years, you'd be at $432,000. So as you can see, the jumps aren't a whole lot at first. Like that's 25,000 and then a little more and then a little more. But towards the end there, we're making jumps of 60, 70, $80,000, and that would keep on happening, folks. Another 5% of that's going to be 20 grand just in 1 year. But then so that'll be a huge jump over 5 years. So it's really starting to escalate. There, folks, is exponential growth. So there's our formula. Make sure we convert our rate of increase to a decimal. Use your calculators. Yeah. Let me know if I can help.